Welcome back to the Yamaha RX500 repair part 3. If you haven't seen the previous two videos, you should see those before jumping in here because I'm kind of in the middle of things with this video. Just to summarize, I disassembled my RX500 Yamaha stereo dating back to the 80s smoked the other day. I have one video showing how I took it apart. Next video, how I made an attempted repair that failed. And this video is going to follow on from that. Basically, at the end of the last video, I had made a determination that I really wanted to fix this thing, even though my first attempt failed. And what I did next is I really thought hard, and I say, you know, I'm not a real expert in these audio amplifiers, but I do understand all the individual components, the transistors, the resistors, the capacitors, what have you. And if I make sure every one of those works, the amp should work. So what I did was I have here the schematics, and I'll zoom in a little bit in the suspect area. There's basically 1, 2, 3. There's a bridge rectifier here with 4 diodes. There's 4 diodes here and a diode here coming off this transformer. And this bridge rectifier generates plus 44.9 and minus 44.9. This set of 4 diodes generates plus 12 and minus 12. And I think that's for the processor, the radio part. I don't think I had any problems with this, but I decided to pull all these diodes. And then there was one more here that does a half wave rectification. I don't know what that's for, but I pulled that. So the whole idea here was to isolate the transformer. Because I blew this fuse, I knew if I just put a new fuse in and powered it up again, it would blow again and I wouldn't learn anything. So by isolating the transformer, I figured I could at least power it up and see that I didn't blow the fuse. So I pulled all these diodes out of the circuit, isolated the transformer, powered up. It behaved as expected, which is great. So then I knew, okay, I'm going to do this progressively, very methodically. So I put these 4 diodes in on top. And of course, when I had all these diodes out, there was no power over here. So, the receiver looked dead. So I put these 4 diodes in because I figured there was no real issue up here. I hadn't touched this area. There was nothing related to this area that was giving me trouble. So I put these 4 back in, powered up again, and the front of the receiver came to life. And most of the controls worked. There's a couple controls that didn't work. So I was hoping it was this extra diode would fix the last control. And so I powered off, put this diode in, powered on again, and then the whole front panel worked. So then, and no fuse blowing or smoke or any funny noises or anything. So I knew this section was good up here. And the problem was down in here. So I showed before in my previous video how I had jumpered in like 3 jumpers all over to plus B, which is right here, because the burned part of the PCB looked like it was all going to plus B, and there were 3 jumper wires in the board just hanging out there. And so I assumed everything went to plus B. So what I decided to do is I put 1 wire at a time back to plus B until something happened. So what happened was, so I put this rectifier back in with none of the jumpers connected. So only what was connected on the PCB. powered it up again, and the rectifier looked good. I had on the plus side of the rectifier, I had 44.9. On the negative side, I had minus 44.9. So I knew the rectifier was good. I had good stable voltages. So then I connected one of the wires, powered up, and no blown fuses, nothing out of the ordinary happening. Powered off, connected the second of the 3 jumpers I had added. Same thing. Well, the third one I went to connect, and I just touched the wire on the plus B output from the rectifier, and there was a spark. And I says, oh, something's wrong here. And with this last wire, it shouldn't have sparked. It looked like a capacitor, a fairly hefty capacitor discharging. And I thought, well, there's something wrong here. So I didn't even bother connecting that third wire and powering up. And I started digging and digging. And I realized that minus B and plus B were shorted with that wire. If I connected that wire here, I had plus B and minus B. Well, no wonder the fuse blew, right? Because I basically had a short circuit. So then I went on the internet and started digging more. And so basically, I found a different site with a RX500 service manual, and it included this image of the PCB, so I could see what was supposed to be where the burnt section was. Except the only problem is down here right on the edge. So there's the other part. So it was across 2 pages, and the rectifier is right there, right crossing 2 pages. So that wasn't ideal. So what I did was I basically brought up both pages, put it next to each other, and did a screenshot. And this is the section here where the copper was all burned out. And you can see it connects to the plus side of the rectifier, that plus sign there, and it comes over here. Well, it's a little hard to tell because it's right between pages and there's a little piece missing. And it comes over here and basically comes down to here. So where this J253, that's one of the jumpers, and that's the plus B. Well, I thought, because this whole section was missing, I thought it was all connected to plus. But in reality, you had this J252 jumper coming from over here, which actually came down from up here minus B. And that's why plus B and minus B were shorted. And then it jumped over to this transistor on J255. So these jumpers only go horizontal and vertically. So he couldn't go directly over here. He had to go over here and then down. So I was totally fooled. So I was connecting all 3 of these wires together, which shorted plus B and minus B. And in retrospect, I should have looked in more detail at the schematics. I could have figured where these things were going. But as it was, I just assumed it was just one copper area that was burned out, and it was really 2. Now, why both these areas are burned out, I don't know. I still don't know. But anyway, so here you have the area that was burned out, 3 traces, 3 jumpers, and 2 different traces. And I had shorted them all together. So then what I knew I could do is I could just take this jumper, instead of going to here and then down to here, I could just jumper it directly to here and over to here. So at that point, I figured, okay, now I got to understand why this thing burned out. Because if I just plug it in again, it'll probably, with new part components, it'll probably burn them out again. I had already replaced Q217 and 215 because Q217 had a damaged leg. I showed that in the last video. And 215 was also replaced because they came as a pair. I don't know if they have to be a match set or whatever, but I just decided to replace both of them. But now I knew kind of why my fix caused the fuse to blow. And then I decided, okay, now I got to figure out what happened in the original problem, because I still didn't know that. So I did some basic probing of these transistors, and I found these two guys were both burned out. They were both shorted now. So by shorting plus B and minus B, I blew both these transistors. And I started getting nervous. So I pulled out this transistor, and the power transistors along the side here. Let me, there. So anyway, the other thing I did, even maybe before I pulled the transistors. So here's Q219, Q220. These are the power transistors I decided to pull out. Just because I figure if I plug this thing again, I don't want to blow all these power transistors. And then the other thing I did is I started looking this plus B and minus B. I took these schematics and put them in a this editor, this drawing program, and I basically took ground, which is the purple here, and I traced all the ground lines, highlighted all the ground lines. And yellow is plus B, and green is minus B. And I looked where there could be a short or a problem that could have burned a hole, up there. And so this is kind of the picture of the schematic after I highlighted ground, plus B and minus B to make it easier. And I really, this side of the circuit, this channel seemed okay. So I was pretty much focused up in this channel, kind of in this area, because although plus B, I basically stopped it whenever there, tracing it whenever there was a large resistance. There is only a 10 ohm resistor here, so potentially there could still be quite a bit of power going through here. I don't know if 10 would limit it enough to 5 amps would blow a fuse if it was shorted to ground. So potentially it could have been on this side. So I started looking at all these transistors. I pulled these power transistors off the board. Then these two guys, which I could tell by using the diode checker, even when it was in circuit, I could tell I had blown these when I misconnected the reconnection. And then what I started to do is basically, before I wanted to turn this thing on, I really wanted to find out what the original problem was, and I don't think I identified it. I mean, maybe it was that bad lead on that transistor that I found initially, but I wasn't sure. So I started going through all these transistors and checking them, both in circuit. In a lot of cases, I pulled them out of the circuit. Check for shorted capacitors, resistors that were shorted or opened. So I basically went through this whole circuit with my multimeter. using the diode checker on transistors, and went through as much as I can. Like I said, these two I knew were bad because they were shorted after I blew the fuse. So this is the other thing. I had to order another set of those. So anyway, I started going through this, and right next to these power transistors, there's this Q213, which is a TO92 package, and I couldn't tell in circuit. There's two of them. There's one on this good channel and one on the bad channel. Basically, a 2SC2240, both of these are. And the interesting thing, if you look at the schematics, it's both labeled Q213, so there's a couple of errors in these schematics. But anyway, I knew which one was which. And I couldn't tell in circuit with the diode checker whether it was working or not. So I pulled both of these. And of course, this one down here was good, but this one down up here was shorted. So now I had another IC to replace. So I ordered these things. They were dirt cheap. I got 100 for like $5. So I got a new one of those. I got a new one of these. And then, before putting all this stuff back in, I wanted to make sure there wasn't something else wrong. So with this guy out, this guy out, this guy out, power transistors out, I believe I left this one in. I powered up again. And the schematic had voltages on a lot of these traces, so I could look and see if I had the right voltage. And here I was up here around this one that I had to replace. It's showing like 17 volts here, a half volt here, 1 volt here, and this thing was showing 44 volts. And I'm thinking, is something wrong? Still wrong? And I checked all the resistors. I could not find any bad components in this whole area here. I basically searched this whole area. And I said, well, maybe the voltage is wrong because all this other stuff's not plugged in. So I plugged in so actually, before plugging these guys in up here, I took the good channel. I put the power transistors back in. I powered up, hooked up a speaker, tuned to FM station, and this channel worked. So I knew this half was good, so it was a good example. So I powered off again, and I decided, what am I going to do next? I really searched hard trying to find a bad component here, and other than these 3 transistors, I could not find anything. So finally, I decided, okay, I'm going to plug in these 3 transistors and power up, plug in the power transistors, power up, and hope for the best. I had this section, that I had pointed out earlier. I had that jumpered correctly now. I basically had this J253 going directly over to here with my replacement jumper instead of going to, the 252. 253 goes here. Nope. See, this gets so confusing. Anyway, I jumped from here over to here, and then this one goes to here. But anyway, I got that wired correctly, I believed. I use an ohm meter to check out for shorts and stuff, and it was a little hard to do because of all the circuitry in there, but I think I had it right. So anyway, I had everything plugged back in. I turned it on and crossed my fingers. And it came up. No blown fuse. I checked voltages. Voltages look good. I plugged in a speaker and put it on an FM station, and voila, I had sound out of both channels. So I fixed the unit, and I was like so happy. Now I did do one additional thing. There was a in the manual, there's a section on calibration. So I pulled up that section and I did the calibration, then hooked up both the speakers. And you know, the darn receiver sounded more musical than it did before it blew up. So this thing must have been failing for a while, because I very surprised to me that the sound sounded so much better than it did just before it blew up. So it either could have been the calibration I did, which was very simple. I mean, they have two parts to the calibration. One's the radio, and I didn't bother with that because I never touched anything over in the radio. And then there was a couple variable resistors here. One here, one on each channel, and you're supposed to set the current, the voltage drop across these resistors to be between 10 and 15 milliamps, or millivolts. And I did that. This one here was way off. It was like 80 millivolts, so I had to turn it way down. This one was pretty close, and it's funny how you change one and the other one moves a little bit. But anyway, I tweaked that. The receiver sounds great, and now it's time to do a little demo. So here I have the stereo working. Everything's working on it. Loudness. Balance, right, left, loudness, treble, bass, this thing has a bass extension that really helps these small speakers I'm using. And both speakers work, volume works, everything works. So I'm in pretty happy with this right now. That's about it.